Alright, here's the practice test for Trig Part 2. This looks just like the real test, and I'm going to kind of go through and give you some pointers as we go here. On the top part, you need to find the period and amplitude for each of these, and then on 2 and 3, you're going to actually give me the equation as well. Let's just do the period and amplitude first. The period, remember, is from a starting point to a starting point, or anywhere on here. I'm just going to go dip to dip because that'll be the easiest. So from -3 to 2 is a distance of 5. Again, I could do it from anywhere on here. I could do it from here at 1 to -4. That distance is 5, and so on. Okay. The amplitude itself is, remember, the highest point, which is 1, minus the lowest point, which is -1, all over 2. This should always be a positive value, and it's always going to be over 0. So if you were to just put 1 minus 1 here and get 0 over 2 to get 0, that obviously would not work. Here we'd zip zap, 2 over 2, of course, is 1. On problem number 2, the period, let's start it. If I start here and go to here, it's kind of hard to see. If I start here and go to here, it's kind of hard to see. But if I start at the beginning of the function and go up, down, down, and up, you can see it goes from 0 to 2. Now again, the significance of this, let's go amplitude, 2 to -2, 2 minus -2 over 2, 4 over 2 gives me 2 here. Now, I know that this starts at 0, so this is a sine function, and I know that it's going up, down, down, and up, so I can go positive amplitude, and my amplitude is 2. And then how do I get that b? And I get that b by doing the same thing every time. I set 2 pi over b equal to the period itself, which is 2. Put that over 1, cross multiply and divide. I get 2b equals 2 pi, and divide both sides by 2. Those cancel, b is pi. And I always put an x on it at the end, or a theta if you liked those little theta symbols, which most people don't. Alright, the period here starts here, ends here, that's a distance of pi. Starts here, ends here, that's a distance of pi, and so on. The period here is indeed pi. The amplitude goes from 1 to -1. Again, 1 minus -1 over 2 gives me 1. And this does not start at 0, so this is a cosine graph. You're going to get one sine, you're going to get one cosine. And it's entirely possible that one's positive and one's negative. This is supposed to start at 1. So if it starts at -1, then it's a -1 cosine, or negative cosine. Again, to find my b, I'm going to take 2 pi over b and set it equal to my period, which is pi, cross multiply, and divide. Those cancel, b equals just 2, and then put an x on there. And I'm done with that. Okay? Now for the next part, you're going to get the unit circle up on the overhead. And the unit circle is going to have all these points. And what you need to know is that sine is the y value and cosine is the x value at those points. So when you see the points like this, x, you're not going to see x and y. You're going to see actual values in here. The x value of the point is the first point. That is the cosine. The sine is the y value. So the cosine at pi over 3, if you go to pi over 3, which on your unit circle is, this is pi over 6, pi over 4, pi over 3 right here. It's further up than it is over, so the y value is going to be bigger, which is square root of 3 over 2, and the cosine is 1/2. You don't even have to remember that. You just need to remember x is the cosine value, y is the sine value. It should be really easy. Go to pi, the cosine value is -1, sine value is 0. That's right here, by the way. That's why. 7 pi over 4 is going to be right here. That is going to be, anything over 4 is going to have square root of 2 over 2 and square root of 2 over 2, but then because it's over here, it's down, the sine value is negative, the cosine value is positive because it's to the right. And then 4 pi over 3 is actually over here, and that is, again, further down than it is over, so I'm going to have 1/2 and square root of 3 over 2, and because it's in the third quadrant, they're both negative. You will lose points for not having the correct sign. Okay? Sketch a periodic function with a period of 3 and an amplitude of 2, which means that my points have to be 3 apart, on top and on bottom. And then the amplitude, well, if you think about amplitude, remember you find the amplitude by taking max minus min and dividing it by 2. So if my amplitude is 2, well, then I would times both sides by 2, and the max minus min better be 4, which means that the distance from the top point to the bottom point should be double what the amplitude is. So I'm going to very simply go 3 up, or excuse me, go 3 up and 1 down so that my points are 4 apart. Can you go 2 and 2? That's fine. You can go all 4 up here and 0 here. I don't care as long as they're 4 apart. And I know I need my points to be 3 apart, so I'm going to start here, 3 apart, 3 apart, 3 apart. I'm going to go to this line here because I'm again 4 apart this way. Start here, go 3 apart, go 3 apart, go 3 apart, and then just connect my lines. I did not say that you have to make this a wave, so if you want to be creative and do something else, you have at it, okay? But it should, at minimum, have, you must have at least 2 cycles. So if you just drew that would be acceptable, okay? Or if you just drew that, but it should have 2 full cycles within it to get your full credit, okay? All right, down at the bottom, this is the only place tangent is going to come into effect, and it's going to be really easy if you remember that the vertical asymptotes, I'm going to write it over here, vertical asymptotes are found by going pi over 2b. If I know that, and I know my vertical asymptote is right there at pi over 6, then I can just set pi over 6 equal to pi over 2b, and cross multiply and divide. 6 pi equals 2 pi b, and divide. It's always cross multiply and divide. Those cancel, those cancel, those cancel. B is 3, and look, the only place where b is 3 is right there. The answer will be obvious if you know how to work it. Don't let this be something that throws you off in thinking that that's the answer. Don't let this throw you off in thinking that that's the answer. Those are not correct. And this 3 is my amplitude. Don't let that 4 throw you off and think that that's there too. Really, what happens here is the points cross at that point at 2, right? Here's 2. Halfway, 2, it makes a point. Halfway, at 2, it makes a point. At -2, it makes a point. So there's another way to look at it. It's where the points kind of cross should also be your amplitude, okay? But more than anything, just set pi over 2b equal to pi over 6, and you'll have it, or equal to whatever the vertical asymptote is. And the only option you'll have is the b there. Okay? Next page. Up at the top, we're going to do these graphs all the same, where we're going to do 2 bars here, we're going to do 4 bars here. If you remember, I always kind of split the difference here. I'm going to do the same thing on number 11. Alright, the period and amplitude should be really easy. At least the amplitude should, because it's always that number. And it's always that number. But remember, the amplitude is a distance, so don't put -3 here. You'll lose a half a point. The period we can find by going 2 pi over b. So here I go 2 pi over my b. When there's nothing there, remember that means a 1. So my period is 2 pi. That's significant because I need that here, and then half of that here. The amplitude goes here. We always start signing at 0, and it's up, down, down, and up. Up, down, down, and up. Okay, there's that graph. For cosine, again, it's still 2 pi over b. b here is 2. So 2 pi over 2 would cancel to give me a period of pi. And that goes at the end. Half of that goes here. If you put 0.5 pi, that'll also work. The amplitude goes here. Now again, cosine, sine starts at 0, cosine starts at there, unless it's negative. So I need to start here, and then up, up, down, and down. Remember, it should be a ditch if it's a regular cosine. It should be a hill if it's negative cosine. And there's that. That's it. That's all you got to do for those graphs. Okay? We get to the calculator part. And of course I forgot my calculator again, but I'm going to still kind of give you an idea of how this works. Okay? So remember again a couple of more things here. Up here, I'm sorry. This is up, down, down, and up. Unless, of course, there's a negative in front, then I go the exact opposite way, okay? And we always label the period and half period, okay? The same rules apply here, except for, again, this was negative, so I flipped it. Flip it will be in either one of these, same rules in terms of labeling. Now, the first thing you want to do here, and it should already be, but let's make sure, is make sure your calculator is in radians. That's kind of significant, or a lot of this is going to go wrong. For part A here, for part A, this part right here, all we're going to do is take the radians times the radius. It is really that easy, okay? For the area of the sector, and I'll probably put this actually on the board, is degrees over 360 times pi r squared over 1. So, for number 12, I've got pi over 3, the radians, times the radius, which is 2. I'm going to put 2 over 1, and literally you can go pi times 2 divided by 3 and get your answer, which is 2.1 feet. It does say round to the nearest tenth. That's all I got to do there. I'm not finding an area, I'm finding a length. Okay? I'm going to do the same thing in A on this problem. Again, make this easy. It's just the radians times the radius. I can go 11 times pi times 16 divided by 6, and I'm going to get 92.2, and again, centimeters. Make sure you're labeling these. That's the way it works. Next problem, I need to convert this to degrees, but if you just look at your, now you can do that by going pi over 3 times 180 over pi and reducing to get 60. Or you can look at your unit circle and pi over 3 is 60 degrees, but you should know how to do this way just in case it's not on your unit circle. So I get the degrees over 360 times pi times the radius squared. Okay, and you can literally go 60 times pi times 2 squared of 4 divided by 360, and you're going to get 2.1 feet squared. Area is squared. These are never really going to be the same. This happens to be just an anomaly. This doesn't happen very often, and it won't happen on the test. But so don't just rewrite the next answer as some feet squared. Okay? Go through the work. On this one, 11 pi over 6 times 180 over pi. Cancel those out. You can just do the math. 11 times 180 divided by 6 in your calculator. I know 6 goes into once and 30 times, and so that's 330 degrees. So I'm going to go 330 over 360 times pi times the radius squared. And again, 330 times pi times 16 squared divided by 360 will get you 737.2 centimeters squared. You can plug it in exactly how you see it in your calculator. Okay. Number 14 through 16 is the ones on the calculator. Again, make sure you're in radians. Okay, I'm going to kind of write a couple of little hints here. Left side is y1. Right side is y2. Then you press graph, which is the button to the far right of your calculator. Then you're going to press second, and then trace, and you should see the word that says calculate. Above trace says CALC for calc, and it's going to say calculate on their screen when you do that. Then you're going to press number 5, just 5 by the way, that's intersect. Then you got to get close to point of intersection, and hopefully you can remember this, because then you just literally press equal, or enter, excuse me, enter times 3, enter, enter. Then you need to do it all over again. You go to the next point of intersection. You go second, trace, 5 for intersection. Use your right button to get closer to your next point of intersection. Enter. Then you do the same thing. Second, trace, intersection. Use your cursor to get to the next point. Enter. I'm going to put the answers here. 1.83, 2.88. Again, it says round to the nearest hundred, so that's 2 decimal places, by the way. 4.97, 6.02. When it says from 0 to 2 pi, that means I don't want any length past 6.28. I'll put that here, 6.28. I don't want anything past that. Here I'm going to have 0.83, 1.26, 2.93, 3.36, 5.02, and 5.45. And for 16, it was 1.15, 2.95, and 4.74. If you're really confused as to how to do these, make sure you're talking to me before you take the test and just I can show you a quick reminder. But I really broke it down here. You go to y equals, so maybe I should write that first, y equals, press that button first. Your left side is going to be y1, so this. Your right side is going to be y2. Press graph, second trace, 5 for intersection. Get close to the point of intersection, enter, 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 and it tells you the values. Okay. Do it again for the next problem. Left side, right side, y1 and y2. Graph it, second trace, 5 for intersection, and I want you to find all of them between 0 and 6.28. That's why I don't have anything past this. That's why I don't have anything past this. That's why I don't have anything past this. And you're not going to get any negative numbers, so don't go left ever on any of these. Okay. Now here's the thing. When you get this test, you're going to get the whole thing. You're going to work through number 11, and as soon as you get done with that, you're going to come up and show me, and I'm going to give you a calculator to do the rest. Okay? That's it. Good luck. Study. Have a good day.